we're going to talk about how to add and subtract rational expressions. First, we're going to look at adding and subtracting when I have monomials, which means I have one term in the denominator. What you want to think about in these problems is keeping up with the Joneses. So I want to have the same thing in both my denominators. So if I look at this first problem, 10a, 5b, well, my second fraction is off by a factor of 2 over 2, because 5 times 2 would give me 10. And while I'm with that fraction doesn't have an a like the left one. But now, if I look at the one on the left, it is missing a b. So I need to multiply by b over b. And you don't need to write this next part unless it helps. What is b over b? 1. What is 2a over 2a? 1. When I multiply by 1, does it change anything? No. But what will be nice, now that I have done that, is I will have a like denominator. So if I multiply across my first fraction, I end up with 9b over 10ab plus 4 times 2 is 8a squared over 10ab. And now I can combine the numerators. 9b plus 8a squared all over 10ab. And at this point, I would factor the numerator and make sure there's nothing I can reduce to 1, but there's nothing that I can do with 9b plus 8a squared, so this is my final answer. And obviously, it's still the case that a can't equal 0 and b can't equal 0, just like yesterday. Okay, so moving down, I'm just going to clear off this. I have a 5 in one denominator and a 3 in the other. So I'm going to have to start off by multiplying my one on the left, definitely by 3 over 3. And the one on the right by 5 over 5. And now I'm going to see if there's anything else that I need. Do both of them have an a? Yes, but the one on the right has an a squared. So that means the one on the left, I need an extra a. B cubed and b squared, that means that the one on the right needs a b. And what am I really multiplying both these fractions by? 1, which doesn't change anything. So that gives me 6ax over 15a squared b cubed plus 20y b over 15a squared b cubed. So if we did this right, our denominators are the same, which means I can add my numerators. 6ax plus 20y b all over 15a squared b cubed, and a cannot equal 0, and neither can b. Okay? And once again, I could factor that, but since I have a monomial in the bottom, there's no way I'm going to be able to simplify this. And my last one. One has a 3, one has a 2, so that means I'm going to have to multiply by 3 over there, by 2 over here. Sorry for that 2 being hideous. Let me fix it a little. Whoa, that's big. Okay. One has an x, one has a y, so here we go. That gives me negative 14 x y squared over 6x y plus 12 x y squared over 6xy And notice now I do have like terms in my numerator. So if I combine those, I would get negative 2 xy squared over 6xy. And then that would simplify. My x's will reduce to 1. One of my y's will reduce, so I will end up with negative 1 over 3 with the y in the numerator. So negative y over 3. Now, you know what would have been smart is if I followed my steps and did what it said at the top. So let me show you what would have happened if I had recognized that my right fraction can simplify. So this is the same problem, but simplifying this first. Do you see how there's a y squared over y? And I have a 4 over 2. So that means I could rewrite my problem as negative 7xy. And look, we have an x2. So let's reduce that as well. Negative 7y over 3 plus 2y. Well, then I just want to simplify this right fraction by multiplying by 3 over 3. And that would give me negative 7y plus 6y all over 3, which would be negative y over 3, the same answer. So if I had reduced first, it just would have made things a little bit easier. So either way of those would be totally correct. And that wasn't a big deal, but when we move on to these bigger rational expressions, it's going to be more irritating if we don't do that. Okay, so now we move on to something where we don't have monomials in the denominator. It's the same idea. We need to factor the denominator, and then we need to compare our factors. So do all my fractions have an x minus 1? No. So I need to multiply the ones that don't have an x minus 1 by x minus 1 over x minus 1. And then I look at the x plus 1. Do both of them have an x plus 1? No. So I need to multiply this one by x plus 1 over x plus 1. What am I effectively multiplying by? 1. So am I changing anything? No. Now what I need to do is simplify my numerator. So if I simplify my numerator of my first fraction, I can either FOIL or use the box, and I should get x squared plus 3x plus 2. Oh, wait a minute. Whoops. That was supposed to be an eraser, y'all. And then if I simplify my right fraction using FOIL or the box, I should get x squared minus 4x plus 3. And now these are over the same thing, and I'm going to leave them factored right here. So we want to multiply out the top, but leave the denominator factored. All right. Now, notice what I put around my second fraction. I put parentheses around the top because when I combine these into one fraction, I need to remember to distribute that negative because it has a minus. So I'm going to put my denominator, it's staying the same. And then I have x squared plus 3x plus 2. Stop, we need to distribute our negative. Minus x squared plus 4x minus 3. Now it's just basically plugging some numbers in. So my x squareds, those are going to reduce to 0, so those cancel. I have a 3x and a 4x, so that will become a positive 7x. 2 minus 3 would give me a negative 1, and that's all over x plus 1 times x minus 1. Can I simplify what's in the denominator and multiply it out? Sure, have at it. I'm just going to leave my answer like this. There's nothing that's going to reduce in the numerator and denominator. And x cannot equal negative 1 and positive 4. Look at this one. Now, this one has not been factored for us, so the first thing I need to do is factor my denominator. So leave your numerator how it is. That first one, looking like an x factor to me, multiplies to 6, adds to 5. Should be 2 and 3. Next one looking like an x factor 2, multiplies to 4, adds to 4. 2 and 2. All right. So let's compare our neighbors. I have one x plus 2. I have another x plus 2. But are my remaining factors the same? No. I have an x plus 3, but I don't have one over here. So I need to do x plus 3, x plus 3. So now that part's the same. Next, I have another x plus 2, so I need to multiply by an x plus 2 on the left. Yes, it matters that I don't have two x plus 2's in the denominator. And this one is a lot nicer for me to simplify because I don't need to use the box. I just need to distribute. So x times x would be x squared. X times 2 would be 2x. I'm just going to write it as x plus 2 squared to save time. Minus, distribute your 2. 2x plus 6. Don't forget you need the parentheses around that numerator. Now I get to distribute that negative and combine everything into one fraction. So I would have x squared plus 2x minus 2x minus 6 all over x plus 2 squared times x plus 3. What's nice, my x's in the middle are going to cancel, so I get x squared minus 6 over x plus 2 squared and x plus 3. Now don't make some magic happen here because you want to go all crazy canceling stuff. There's nothing else that's going to reduce here, so I just need to state that x cannot equal negative 2 or negative 3. Move on. Okay, another kind of baby problem. First, we need to factor the denominators. X minus 5 over, they both have a GCF, 2 times x minus 3, minus x minus 7 over GCF of 4. 4 times x minus 3. What is sweet about these ones? They both have an x minus 3. Cool beans. But I have a 2 and a 4. Now, I could multiply the first by 4 and the second by 2, but what would be really convenient is if I just multiplied my first fraction by 2 over 2. Because if I multiply 2 by 2, I get to 4, which is what I want. So I don't want to make more work for myself than I have to. I'm just going to do the simplest thing I can. So that would mean I need to do 2x minus 10. I'm just distributing that 2 over 4 times x minus 3 minus 7. All right, so let's combine. So 2x minus 10 minus x plus 7 all over 4 times x minus 3. 2x minus x is x. Negative 10 plus 7 is negative 3. Hey, over 4 times x minus 3. Why am I excited? Well, here's why. I have x minus 3 on the top and x minus 3 on the bottom. Now, don't tell me the answer is 4. The answer is not 4. The answer is 1 over 4, except for x cannot equal positive 3. So it's going to look like a horizontal line, but it will have a hole at 3. I believe we have one more. Here we go. I'm seeing a difference of squares as soon as I look at this problem. Now we want to start with factoring the denominator. So I just rewrite my numerators. 1 multiplies to 1 and adds to 2, 1. I just get in the habit of putting my second numerator in parentheses. X plus 1 times x minus 1. Okay, so at this point, I could do a couple things. I could find my common denominator like I have in the other problems. The smart way to see this problem is that I already have some like factors going on. I already have an x minus 1 over an x minus 1. So I could rewrite this second fraction as 1 over x plus 1. The other thing I could see is that 3x plus 3 is the same as 3 times x plus 1. I could factor the numerator. And if I factored that numerator, look at what I have in the denominator. I have an x plus 1, which would mean this first fraction is 3 over x plus 1. Now look, I have a common denominator here. So I could just go ahead, add my numerators, and put it over my denominator. I do need to remember that I took out a positive 1, so x cannot equal positive 1 or negative 1. Now, let's say I didn't realize that I could reduce some stuff to 1 at the beginning. Could I do this problem another way? Sure. Let's go back. Go back to where we factored. I've lost my mind. I don't see that this numerator is going to factor to something that will reduce. So what do? I keep up with the Joneses. My one on the left has an extra x plus 1. So I need to multiply my second fraction by another x plus 1. My second fraction has an x minus 1 that I don't have in both. So I need to multiply my second fraction by x minus 1. Once again, all we're doing is multiplying by very specially chosen ones. And now I have a whole hot mess that I have to distribute. Do you see why it's easier to recognize that we need to reduce first? So this would simplify using the box or FOIL. 3x squared negative 3x. Ooh, that's going to reduce. Minus 3. Plus, I'm going to go ahead and box or FOIL the next part. That's a difference of squares. X squared minus 1 all over x plus 1 times x plus 1 times x minus 1. Okay, let's reduce that baby. 4x squared minus 4 over x plus 1 times x minus 1 times x plus 1. And how could the top factor? 4 times x squared minus 1. I'm not going to write that whole denominator, which is 4 times x plus 1 times x minus 1. Now I'll write the denominator. X plus 1, x minus 1, x plus 1. Do you see how much longer this is? Whew, okay. So what reduces to 1? X plus 1, x plus 1, x minus 1, x minus 1. So what do I end up with? 4 over x plus 1. Just what I got in the other one. It just took way more work. So think smarter, not harder. All right? That's all we got. Fill out the questions at the bottom of the video. See you tomorrow.